Now, our general form for the tan graph is that. Okay? Okay? Now, the basic tan graph is y equal to tan x. Okay? That's your basic tan graph. Y equal to tan x. Okay? Now, the basic graph of sine is y equal to sine x. The basic graph of cosine is y equal to cos x. Now, the basic graph of tan is y equal to tan x. Now, the tan graph, okay, it has got some unique characteristics. So what I want you to do is take out your calculator. Take out your calculator. Before you start sketching anything, you need to take out your calculator. Because for you to be able to sketch the graph, it comes from doing a table of values. Okay, so with your calculator, right, as usual, don't start sketching anything because you need to pay attention first. Okay, you take out your calculator. I expect you to have your calculator in front of you. Alright, so you go to mode, then table, f of x. This time we are putting tan. Okay, I expect all of you to be gurus by now. Yes. Of using your calculator to do a table of values.
So if you're not a guru,
Okay?
I'm a guru. Guru is a teacher.
Alright. Yeah, then it means if you end up becoming a teacher of the calculator, then it means you know how to use it. Alright. So f of x equal to tan x. Now we are starting from 0 degrees and ending at 360. And the step here. Now the step is gonna change. It means step. In my calculator is, I think it's in German or Dutch. Alright. Okay. Alright. Now pay attention carefully. Now the period of the tan graph, our function is y equal to tan x, this one here. Can you look at right? Now the period of a tan graph is not 360 like sine and cosine. Okay? It's 180 degrees. It's 180 degrees. Okay? Now when you want to find the step for the tan graph, it's not 90 degrees like how we're doing the sine and cosine graph. The step on the calculator is going to be the period divided by 4, which will give you 45 degrees. Okay? So when you are putting your step for the tan graph in this grade, you put 45 degrees if you are asked to sketch it. Okay? So where it says step here, you put what? 45. Please do me a favor. As I'm doing it, you must also be doing it. Okay? The only way you can master how to use the calculator is by using it. So press equals there. Then it gives you that table. Okay? Now you are going to find that for the tan graph, some of the y values will say error. Okay? Where it says error, it means you are going to have an asymptote there. Remember, when we were doing the algebraic graphs, the hyperbola and the exponential function, we drew asymptotes. Okay? Now the tan graph also has asymptotes. Now those asymptotes, you find them where y is undefined. Like here, when x is 90, the y value says error, which means there's going to be an asymptote at x equal to 90. That's why I drew an asymptote there. So when you are sketching the tan graph, you start by drawing your x and y axis, then your asymptotes, after labeling your axis. So I drew the first asymptote, it's here, where x is 90. Then when you scroll down, if you go to 270, the y value when x is 270 is also undefined. So we have a second asymptote. Okay? Now we are only sketching from 0 to 360 because that's the basic domain for grade 10 from 0 to 360. So you have two asymptotes. Okay? Now when you do that, you go back to your calculator, you start plotting all those points. So when x is equal to 45 degrees, y is going to be 1, which is this point. Okay? It's a very important point because it appears on the calculator because tan 45 is 1. Then another critical point is going to be 135 degrees. It's also on your calculator. Obviously 180, and we have got 225 here, right? 270 and 90, they are critical points because that's where the asymptotes pass through. Then we also have 315 degrees. Okay, and obviously we have got x equal to 0. All right. So for now, let's draw your x and y axis. Label x in terms of 90, 180, 270 using a ruler. Using a ruler. Okay, and also label your y axis. Now, if you try to do it using doing it manually, it's always wise to make sure that your step is 45 degrees. Okay. Now, if you do it manually, you find that you are going to have lots of x values. So it will be wiser for you to master how to use the calculator because if you do it manually, you take long to write all the x values and the corresponding y values. If it's a test situation, you don't have too much time to waste because there's no mark allocated for doing a table of values. Okay? There is no mark allocated for a table of values. The marks are allocated on the graph. The marks are allocated on the graph. Okay?
So, I don't understand why the thing goes all the way up. I don't understand why it goes all the way up here. Why it goes up here?
No, it doesn't stop. Can you take a
So you
seat?
need to calibrate.
Take a seat. Okay.
I like saying
The main reason. Okay. Can you pay attention? It goes all the way because the values of y, okay, they go as far as positive infinity. Okay, if you put x values from 0, you find that the y values are going to increase. Now, as you approach 90 degrees, okay, as you approach 90 degrees, y will continue to increase. Okay, it will increase exponentially without stopping. That's why the graph carries on up to positive infinity. There is an increase in y values exponentially when x increases and when x approaches 90 degrees. So which means before you get to 90, you can end up having 89 degrees, then 89.9999999 up to infinity. So because of that, it will carry on. It will never approach 90 degrees. Because at 90, y becomes undefined. So because of the fact that the curve is approaching an asymptote, okay, the curve will never stop. It will carry on, but it will get as close as possible to the asymptote, but it will never touch it. Because it doesn't touch it, then it means it carries on exponential until positive infinity. And if you are going down here until negative what? Infinity. Yes.
So why is that point of the way?
Which point?
Okay, that one is 0 and yes, that one.
This is 45 degrees. It's halfway between 0 and 90. It's there on the calculator. You saw that. Yeah. This point is on the calculator. It's 45. Just that I didn't label it here. Use the values that are appearing on your calculator to sketch. And don't be a spectator. Don't be a spectator. Okay?
So what do the Roman numerals represent?
Okay, the patterns. I'll talk about that later. Don't be a spectator like him. He likes to be a spectator.
No, I did it home, sir.
You're gonna hand you our book, so I'll see.
Yeah, I saw.
All right. Just to remind you, all of you as we speak, and he's also a spectator, he's not writing anything down. All right. So that's the first quadrant. Okay, remember, in the first quadrant, tan is positive. Do you remember that from your cast diagram? Huh? So in the first quadrant, y is positive. That's why you see that the curve is mainly in the first quadrant. Okay? Then, on the other side, now I want you to know that this first curve here is half of a full curve. Between 0 and 360, you are supposed to have two full tan curves. So this is the first one. The second one is going to be a full tan curve. Goes like that. Okay? Now at the bottom here where you start from minus infinity as you go up like that, up to 180, that's the second quadrant. Up to here. In the second quadrant is tan positive or negative?
Is that?
Negative. That's why you see that this curve here, the y values are what? Are negative. Do you see that?
Yes.
Well, it's based on the quadrant. Then from here, between 180 and 270, that's the third quadrant. In the third quadrant, tan is positive, so the curve is now above the x-axis because the y values are positive. In the third quadrant, tan is positive. The last one between 270 and 360, it's negative. The y values are negative because on the Cartesian plane or on the cast diagram, tan is negative in the fourth quadrant. So your quadrants, this graph here, it is based on the quadrants. Yes.
Oh, I thought this was the second problem.
Don't confuse what I'm talking about. No. You draw a segment like that. Draw your Cartesian plane, right? 0 degrees here. If you are going that way, that's 90. Okay? From here to there, 90, right? From here to there, 90. There, y is what? Positive. Here, y is positive. From 0 to 90. You see that? Then, if we move on from 90 to 180, y is still what? Positive. Right? But tan, the ratio for tan in the second quadrant is what? Negative. You see, from 90 to 180, the y is negative because in the second quadrant, tan is negative. Then, from here to there, that is 180 to 270, tan is now positive on the cast diagram. And here, from here, going all the way, our y values are positive. Because tan is positive in the third quadrant. So this interval here represents the third quadrant in terms of the ratio for tan. Okay? Then, when you get to the fourth quadrant, tan becomes what? Negative. Now, if you look at this curve here, the y values are negative, in line with the sign of tan in the fourth quadrant. Now, that applies even to the graphs of sine and cosine. Okay? It also applies to the graphs of sine and cosine. Okay? So I expect you to sketch this. So we have got the first curve. Then the second one. Now this one is the full tan curve. Okay? And then this one here, because of the interval we are sketching from 0 to 3, this is just half of it. The other half is this one. Then you end up having two tan curves between 0 and 360 degrees. The period of a tan graph is 180 degrees. So from 90 to 270, that's 180 degrees. So we have a full tan curve. Between 0 and 90, that's half of the period, so we've got half of it. Between 270 to 360, we've got another half, so we've got a second half. This half here and that half will give you a complete one, which looks like that. Okay? So the time graph is a little bit complex as compared to sine and cosine. Right? That's why I didn't want to talk about it on Monday. Sorry, on Tuesday rather. It's because it is a little bit unique. Okay? And in most cases, for some reason, okay, in most test or examinations, you won't see the graph of time, but I'm not saying it cannot be tested. It is tested, but most of the time you get questions on sine and cos. Okay, but you also need to know time because it can also be tested. Okay, so make sure you know. Now, yes.
So where would I use this in that? Like,
It's problem
where would I
solving.
use this to ask something?
It's problem solving.
Okay. All right. The next thing that I want you to do is to sketch the following. The period of a tan graph is 180 degrees. It's not 360 degrees. The step on the calculator is 45. The graph of tan does not have an amplitude because it has no maximum value for y and no minimum value for y. Therefore, it doesn't have an amplitude. Okay? So make sure you're aware of that. Now, I want you